I'm Adam Klaus, and welcome to the Wilkes Land expedition. It's really great to have you all here.
It's the beginning of a great adventure.
We're going to drill.
We're going to drill deep.
We're going to drill really deep.
Good morning, world. Here we are on the far edge of the planet, looking over Antarctica.
We have arrived to our spot. Perfect.
This is why we're here, to study this huge ice sheet.
I love this machine, though.
I know.
The mission for this expedition is really cool. It's understanding and investigating the history of climate since about 40 million years ago. We're going to be looking at the influence of the ice sheets on Antarctica and when they started and how they have changed over time.
It has been a long time preparing for this expedition. Since the time we started thinking about the science, and as you can imagine in science, after 10 years, there is many new things that come up into the plate. So you have to always keep updating this project.
Try to monitor how much sample you need. Obviously, we want to take just enough.
In the Antarctic is obviously, for everybody, it's sort of a fascinating, faraway place where you only have seen pictures of penguins. And to go there, to be able to go there, is just absolutely amazing, of course.
Thumbs up, it's a start.
Pretty exciting. First core, everybody's here. Ice, ice, baby. You come down here because the science is exciting, but it's not a bad place to work in terms of just beauty and natural history, the marine mammals, the birds. You know, I'm fascinated by the animals I see every day. And I make sure I spend time every day looking outside over the ocean to see what's there.
So one of the missions we have on the Wilkes Land expedition is to discover the nature and the timing of first ice along the Wilkes Land margin, and whether it was glacial ice which first arrived here or sea ice. And we're hoping to validate a climate model such as this, which predicts that sea ice occurred soon after grounded ice sheets occurred along this margin.
And then, to understand what the variability was. What causes this ice sheet to decrease in size? What causes this ice sheet to grow? And this is especially relevant as we have seen more and more in the past 20 years, how we have this global warming trend in our Earth. So actually, when we put the proposal, it was more of a scientific curiosity, but as time went by, it became a very relevant societal issue to address.
We've traveled all the way around the world to figure out what's going on.
It's the best day of the cruise so far.
Great cores, great scenery.
I want to see some penguins.
Yeah, it's beautiful.
Ow, ow, ow. I guess.
See the ice cap, 3,000 meters or whatever it is.
I hate this so much. Pretty happy about it. We have 30 scientists, 15 to 20 technicians, and we're trying to form those into teams that work very closely.
We chose the scientists, some of them we knew their expertise, Many of them we didn't know. The scientists have worked very well together. I hope that this enthusiasm that we all have right now, it will materialize in science.
Is this a daily work of a co-chief, Carlotta?
Yes, this is when a co-chief, hands-on, yes.
The way we proceed is actually that we first look at discrete samples, at single samples, and every single sample represents a time slice in Earth history, I mean, that we can date fairly well. And it really becomes interesting if we add all the information from all the samples that we look at together. So we would ultimately get some sort of movie through time, and we could actually witness how the Earth cooled from the greenhouse into this icehouse world, and we could actually analyze the processes behind this. After processing these samples, this is where we actually look at the dinoflagellates that we got from the original sediment.
Fatty alcohols here.
One of the real strengths of an IODP cruise is that you have these diverse but complementary groups of specialists. So there's the physical properties people, the sedimentologists, people doing magnetism, micropaleontologists, and the geochemists. And all of us are working together to extract different but complementary data sets from the cores. And working together, they might be able to tell us quite a lot about how those sediments were deposited.
As a sedimentologist on the ship, we see every centimeter of core that comes up. The core comes on deck, it equilibrates, warms up to room temperature, goes through some measurement systems. We're usually the first to see if there's some big change in sedimentation or a change in color. Bring your camera, follow my finger right over to this. Look at this thing here. Maybe move over there and shoot at it back this way. So this layer here, it's maybe 2 or 3 millimeters thick. You know, that's probably the death event, the end of the summer. In the Antarctic, we have 4 months of kind of bright, warm sunshine. Warm in this case meaning temperatures slightly above zero. And then all of a sudden it gets dark, it gets cold, the ocean freezes, and the plants die. And when they die, you get this big dump. They call it the autumn dump event. This layer of plant debris sinks to the bottom and it makes a layer just like that.
So all of these groups are working together, and all of the individuals in the groups are providing pieces of a jigsaw puzzle, and then when we put them all together we get a bigger environmental picture, and using all of these techniques we can track changes in the environment.
Well, we're disassembling the first logging tool string, and then Kerry's going to rig up the second one. It's going to go down into the hole and measure the speed of sound waves and collect images of the inside of the borehole wall, so we can tell where all the drop stones are all the way down to the bottom of the hole, and fill in the gaps that were missed by the core recovery.
As soon as we drilled the second site and we went through the main objective of this expedition, that was, you know, to cross, leave the glacial world and go back to the greenhouse world, and we were able to see that we had reached that. Then that was the highlight.
Resistance is futile.
How can that be? You know, how can it be so warm that right here in the Antarctic there will be, for example, crocodiles running around?
One of the big unanswered questions in paleoclimatology is what's going to happen to ice, what's going to happen to sea level as we continue to see these rising levels of emissions. If we go back to the Eocene period, there was little or no ice at all on Antarctica. And we're trying to get the first sediments that are taken just close to Antarctica. And with the biomarker measurements that I'm trying to do, we really want to extract 3 key pieces of information. What was the sea surface temperature like? What was the land temperature like? One of the biomarkers we're using comes from soil bacteria. And also, what was the vegetation and the plant types like that may have been blown off or transported from Antarctica into the ocean?
I find it exciting that we can say something about the history of our planet from fossils and sediments. I think that's important for us to understand how the cryospheric system operated in the past to be able to help predict global climate in the future.
I mean, it's kind of funny, you know, I've always wanted to study climate change by looking at sediment records. That's what brought me down here in the first place. And I wrote my very first proposal to work here, and the reviewers said, wow, we don't even know how the sediment gets to the bottom, so how's he going to interpret climate change by looking at sediment cores? So, you know, they're right, actually. We don't have a working model for how this record gets built up.
About 19:20 last night, that's 7:20 in the evening, we started tracking this iceberg about the size of a very large building, and it seemed to be interested in us. And if we look at the plot, we can see that during the evening and early morning hours that it's come directly at us. If we look over here at the expanded scale, we see now that it's at 9 o'clock. We were a little over 3.5 miles from us. We've had a lot of experience with ice. This is the first one where we actually had to deploy the freefall funnel and get out of Dodge. So the decision is made, bring the pipe home as safely as we can.
So on all cruises there's a tension between the amount of time that's been allocated to the ship and the scientific objectives, and often you have a number of different research groups, and those objectives, those sites will be complementary, but sometimes they're also competing as well.
This is the forecast I normally use, and I look at
this particular expedition is kind of even more complicated because of the place where we are. We've got variable ice conditions, icebergs and sea ice. There's also, you know, the very variable weather conditions. It can turn stormy very quickly in the Southern Ocean.
It was known that the weather was going to be a problem, so we made special arrangements, and we got ourselves an experienced weather forecaster, Shell Beckfall, who has been out here 2 other expeditions.
Okay, John, we're up and running, so you're up.
And then we also brought aboard an ice observer who was an experience in both the Arctic and Antarctic conditions, and that was Diego Mello. Those 2 guys presented a formidable team and really assisted us in helping to be such a great success.
Quite a few are grounded bergs as well, what we call fast ice, ice that's attached to the shore.
We don't have a crystal ball for predicting what's going to happen in the future. We do have a tape recorder of how the climate has changed in the past, and that's reflected in the ocean sediments of the world.
We use these climate models as a first stage prediction, and what we find in sediment drill cores on the Wilkes Land expedition helps feed back into these models and refine them. So, for example, the microfossil assemblages that we find and the lithological sequences feed back into climate models to make better predictions.
No matter how good the models are, they're always a simplification of the real world. Whereas with the IODP, we can go back and make these measurements through time, through continuous undisturbed sequences that are not available on land. We can only get them from the oceans. And we're looking at the real world. We're looking at real history.
Quite interesting is that we get from the super greenhouse world, we are getting values that they cannot reach with the models. And that points to a significant sort of gap in the knowledge of the physical atmosphere characteristics or things like that, where the data now show, I mean, you know, crocodiles don't lie. I mean, it means that it was freaking warm. And they, whatever they do, even if they raise CO2 values through the roof, they cannot come up with those kinds of temperatures. And that means that there must be more interaction between the data folks and the model folks. And that's precisely why we're here. We are getting this solid data from the field. They then can use that into their models and to go into a new mode of better understanding not only past climate changes but also future.
Well, we're trying to take the first core, and unfortunately when the core barrel came back, only the upper half was left and recovered. So we lost the lower part of the core barrel.
This is ocean drilling. This is what you get.
Mother Nature is in charge.
Mother Nature.
Mother Nature is in charge.
There's no wrong decisions, just decisions. The planning of every expedition has its own unique set of challenges, whether it's weather, it's ice, it's remoteness, it's difficult coring conditions. We managed to wrap all those up in this particular expedition.
Good morning, final core. Let's go home. We've got a lot of research planning to get the scientists all going on the post-cruise research. We're focused on the future. Now we're going to take these cores and start seeing what secrets they have that tell us about the history of glaciers on Antarctica.
And then the final success will be really measured in the coming years, maybe even a decade as we publish our scientific papers. So it's our duty to do the work to produce the data, but really we have to publish the papers. And then if the climate change story from those papers is important, then that has to go beyond just the scientific literature. It has to be communicated to the public and to policymakers.
So as said, when it was up to me, then all of our 1,000-page thick report would actually look like these two sheets here, these two cartoons, which basically portray both the large-scale tectonic evolution of the ever-widening space, basically, between Antarctica and Australia. The other thing is that the climate has been changing from this greenhouse world here into the ice house, and that this ice house is getting stronger and stronger. And that at the same time, this basin actually developed also partly in a consequence of the enormous power of the erosion that comes from the ice sheets and dumping all of this clay and silt and coarse gravel. And so basically, if you want to know what is the summary of this expedition, this is it.
And this is an international program. And there's people from all over the world joining together for one common goal. They're out here for 2 months, they're living together, they're working in the labs together, and they're trying to answer unknown questions.
Actually, it's one of the best things in the Joides, that you have to have 2 months with these people that you did not know before. And since you have no place to go, you have to meet with these people and talk to these people, and you share experiences that you would not have shared otherwise.
We have chicken, the classic hamburgers, pork spare ribs, sausage, corn on the cob, and a nice table with sweets and salads.
Where else in the world can you have a barbecue and look at icebergs at the same time? You just have to eat fast. Your food gets cold real quick.
This is one of the best ice burgers I have ever tasted.
You really get to know people well. I mean, after a month or two, you know someone as well as if you'd known them for 10 years. You find out all about their family, their hobbies, what they're interested in. And you build up some really, really strong bonds.
Next up, Hobart, Tasmania.
We are in Hobart, and we did it. We did it.
No more ice. Everything without ice from now on.
I miss my family, really.
Good. Thirsty.
You know, you mixed emotions about leaving the boat, but looking forward to having the first nice cold beer in 2 months.
A little bit of flies in the stomach.
Everywhere I go, there I am without you. Every single night another dream about you, but I'm coming home.
Well, I must say, there are some horror stories out there, but this cruise was really a very well-functioning orchestra. Plus, we have a good mix of sort of youngsters who are learning, and they can learn from the older people. Everything was fine.
Wish that I could take you everywhere I go and bask all day in your ever-loving glow. So I'm coming home. Yeah, I'm coming home.
I think it's a very different experience once you've actually been there on this ship, gathering these cores, sailing out there, preparing for everything. It's a whole different game.